Welcome to Bednik Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. We also have a Telegram channel where you can communicate with us, ask us questions, and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Bednik Tutors. Excellence is our word.
A car starts from rest and accelerates uniformly for 5 seconds until it attains a velocity of 30 meters per second. It then travels with uniform velocity for 15 seconds before decelerating uniformly to rest in 10 seconds. 1. Sketch the graph of the motion. 2. Using the graph above, calculate the A. Acceleration during the first 5 seconds, deceleration during the last 10 seconds. C. Total distance covered throughout the motion. That's NEPO 2009/11C. So this is a standard WAEC or NEPO question that you could come across as a student. So our duty is to solve it. But before I do that, I want to appreciate everyone who followed us up in the first aspect of our motion. That's motion 1. Please, I appreciate you. God bless you. God bless your parents. And God bless you as students. Please follow up the motion 2. Those who followed up on dimensions, we will be starting off with soon and many other topics. Likewise, the chemistry too. We have started the International Union of Pure and Applied Chemistry, the IUPAC name, the chemical, how the compound are joined together, the basics of the chemistry. We also started that. So we'll be looking at the velocity time graph, part 2. That's the motion part 2, velocity time graph. This today, we'll be looking at that. Then we'll be able to break velocity time graph down so that you can have a vivid view of it. So as we continue in the journey, your major concern is that for any velocity time graph, it will have either distance and time, velocity and time. That's the major thing we're going to have. Distance and time, or velocity or time. So that you'll be able to know what to do. So here we have in our solution, we have here we'll draw our velocity, like this. This is time on the horizontal. This velocity meter per seconds on the vertical. So that's how it's going to be velocity vertical time second. So for velocity time graph, we have three concepts. Three major concepts. We have the acceleration stage, we call it uniformly formally acceleration accelerated. When the body is uniformly accelerated, we have what we call constant speed. Constant speed. Then when it is uniformly decelerated, when it is uniformly decelerated, accelerated. So those are the three stages. So when it is uniformly accelerated, when it is constant speed in this direction, when it is uniformly accelerated, at this stage It will first of all start at rest at A, move to B, from that B, accelerated, this at rest, will start accelerating uniformly. What uniformity there means, the succession of its velocity can be from 0 to 5, 5 to 10, 10 to 15, 15 to 20. That's 5, 5. That's what we call to refer to as uniformly accelerated. It's increasing with equal velocity with equal time interval. That's what we mean by that. Then constant speed. Maybe when it now got B at 50 meters per second there, after it has gone 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. At 5, 5 interval of velocity. It now got here B to C. It maintained this 50 meters per second for almost, let's say, 10 seconds or 15 seconds. Say it maintained a constant speed before it now decelerating from the 50 again down 40, 45, 40, 35, 30, 25, 30 to 25, 25 to 20, 20 to 15, 15 to 10, 10 to 5. So that's how it's going to be. So till you get to zero back. So that's the two journey a velocity time graph will always have. So you have to take note of that. So let's dive into the main work here. So that's that. We have to take note of these 3 stages. So we move to our work majorly. If we have a velocity time graph, a car starts from rest, accelerating uniformly for 5 seconds. 5 seconds. Since it's starting from rest, accelerating uniformly for 5 seconds until it attains a velocity of 30 meters per second. Here it will go like this, the first stage, go up like this, then for 5 seconds. So the starting point will be 0, 0 here. So this is 5. That 0, 0 means my velocity is 0. My time is also 0. So here is 30. 30 meters per second. Here is 30. 30 meters per second. Then they now said accelerate uniformly from rest. That's where we are starting from here. In 5 seconds. 5 seconds. Then it now said it attained a velocity of 30 meters per second. So that's the 30 meters per second here. We're now told that it then traveled with a uniform velocity for 15 seconds. So this is the uniform velocity now. It then traveled with uniform velocity for 15 seconds. This is the 15 seconds. That 15 seconds will be added to our work here. So this will become 20 before decelerating uniformly to rest in 10 seconds. So we add 10 here. So you see it coming down like this again, making 30. So the first stage, the second stage, the third stage. These are the 3 stages our velocity will have. We have starting from 30 here, it accelerates uniformly 30 seconds. It maintains that uniform velocity, which is also known as constant speed, for the next 15 seconds. Then from there, it's now decelerating the next 10 seconds. So our velocity time graph is done there. So what we are told to sketch the velocity time graph, we've done that. That's number 1. So number 2, we're told to look for the acceleration. Before we look for the acceleration, we are told to solve it using graph. So we'll name this A, B, the edge there, C, D, E, then this will be F. So from our work here, acceleration for A, for question 2, under A, acceleration is known as change in velocity over change in t, which is final velocity minus initial velocity, let's say t2 minus t1. So initial time minus final time. But here, this is not graphically. I'm only explaining this for you to have an understanding of what motion is. So for the graphically now, you look at your initial velocity is A, which is at 0. The final velocity is B, which is at 30. Trace it there. So we'll say B minus A. That's the graphically. You may not even put this. After the acceleration, you can just easily come here. Then time will now be F, final time, minus A. A is standing for both initial velocity and initial time. f minus a. So we can now say 30 minus 0 over 5 minus 0. So we can now say our acceleration is 30 over 5, which is 6.0 meter per second square. So we've done the acceleration like that. So that's all for that acceleration. We move to B. We are told to find the deceleration, which is negative acceleration. So our deceleration will also be d, which is 0 for the velocity, d, minus c, which is the initial velocity, c, over, we will now say, we have d, 0, we trace it to 0. D is for both 30 seconds and 0 meter per second for the velocity, while c for 30 meter per second initial velocity. So then the initial time will be 20. So here will also be d minus e. So deceleration will now be 0 minus 30 over 30 seconds minus 20. So at the end we have minus 30 over 10. So deceleration is equal to minus 3 meter per second square. So if you have deceleration of minus 3 meter per second square, 0.0 rather, minus 3.0, to ensure that your final answer is always in 1 dp. Minus 3.0 meter per second square. If that is settled, that's why deceleration is concerned. Because it's deceleration, you can just ignore the negativity. Because naturally we know that that's a negative acceleration. So see the same thing. So from there we move to C. Why? Because the negativity, it symbolizes deceleration. So it's still like repetition. Even in some scholars, they just put 30 here minus 7, still mean the same thing. That is, they place the C first, but still mean the same thing. But because of the negativity is for you to know that it's deceleration. So let's look at C. C is our total distance travel for the journey. The total distance traveled. Total distance traveled. For the total distance traveled, we have what we call a synonymous to area of a trapezium. Of a trapezium. Which is half open bracket a plus b h. But that's not how to solve it graphically. Solving it graphically means we have to do half open bracket. Here, you can look at this. This is the shape of a normal trapezium. We have a longer distance of a here. A, this will be the short distance of b. Then this will be my height. Or here too, same thing as my height. So for me, I will say AD plus BC, my height, BF, that's my height. So with this formula now, that means we stated it graphically. So permit me, I will clean the board. Our AD from there, our AD is 30 seconds. So we'll say half, open bracket, 30 plus, that's AD, our BC, between 5 to 20. We subtract 5 seconds from 20 seconds, that's 15. Then our height is BF, which is the same thing as 0 to 30. Even you can use CE, still the same thing as 0 to 30. So take note of that. That's 30. So my TDT is equal to half times 45. That's deal with board math first. What is inside? Over 1 multiplied by 30 over 1. So 2 here 1, 2 here 15. So we will now do 45 times. So 45 times 15. That will be 675 meter. So our total distance is 675 meter. And that was all. So it's very simple as ABC.